Okay, we're going to get into rational functions. And just like I told you before, whenever we enter a new function, we learn how to simplify the expressions, graph the functions, and solve the equations. So the first thing we're going to be doing here is simplifying the expressions. And this first one is we're just going to be multiplying and dividing these functions. So before we even get to that, understand what a rational expression is. It's basically a ratio or fraction of two polynomial expressions, such as this one given, is called a rational expression. Now, it basically is just a fraction of two polynomial expressions. This happens to be a constant, but that is considered a polynomial. You could have a quadratic over a cubic. You could have a linear over a quartic. Basically, remember your polynomials. It's one polynomial divided by another polynomial, and that's referred to as a rational expression. However you want to write that in your own words, you don't have to have this exact same thing, but do understand when I refer to a rational expression, I do need you to understand what that means. So because it is basically a fraction, when we're simplifying them, you're just basically doing the same thing you would do when you're simplifying regular fractions, like 8 over 12. This simplifies to be 2 over 3. Well, the way you get that is reducing it each by a common factor, which in this case was 4. But what you're really doing is you're separating this 8 into 2 times 4, separating this 12 into 3 times 4, and these 4's cancel out, and it's equal to 12 over 3. Well, when we're simplifying rational expressions, we're going to be doing the same thing. We have to simplify the common factors with the numerator and the denominator. So if I have a rational expression like this, I know you've always wanted to cross off these x squareds and simplify these x's and things like that, and I've always told you can't do that because this is in a trinomial and this is in a trinomial. They're grouped together. So the way we can do it is factor each of them, and the numerator factors into x minus 3 times x minus 1, and the denominator factors into x minus 5 times x minus 1. And they have a common factor of x minus 1. So what you can do, just like we crossed off these 4 here, I can cancel these x minus 1's out, and this does simplify to x minus 3 over x minus 5. So what we have with this rational expression, in order to simplify, you first need to factor the numerator and the denominator completely. They are slightly factored already. This 5x is factored out, and these are factored into two binomials, but they each can factor more. So let's go ahead and factor them completely. This x squared plus 4x plus 3 becomes x plus 3 times x plus 1. Divided by the x minus 6 can't factor, but this x squared minus 9 does factor into x plus 3, x minus 3. So what I'm looking at now are any of the common factors in the numerator and the denominator. And what I have is this x plus 3 cancels out with this x plus 3, and I cannot cancel this x out with anything with any of the other x's because they're a part of a binomial. It would have to be the exact same binomial to cancel out the binomial, or there would have to be an x out in front to be able to cancel those x's out. So what I have left is 5x times x plus 1 over x minus 6 times x minus 3. And you can leave it in the factored form. That's perfectly fine. So what this question is asking is, under what conditions is this expression undefined? And you're going to get an undefined expression when the denominator is equal to 0. So basically what you have to do, take the factored form that we had before we crossed off the common factors, and basically you're solving that polynomial, that denominator, and that's what x is not allowed to equal. So this means that x cannot equal 6, -3, or +3. Because if x is any of those values, when I plug it in, if I plug in 6 here, that makes 6 minus 6 is 0. Doesn't matter what this one is, 0 times anything, it would make the denominator 0. These are also called your restrictions. You may see it as what conditions is it undefined, or the restrictions. They're both referring to the same thing. So you have to basically, so we're going to call this one example 2. For what value is this undefined? All I really need to do is take the denominator, and it's before you cancel anything out. So I can factor this quadratic into x plus 2, x plus 4. You have the 4x out in front. Because that x is out in front, that means that x cannot equal 0. This means that x cannot equal -2. And this one means that x cannot equal -4. So those are my restrictions, or the values at which it is undefined. Okay, so let's look at one more simplifying, and then we'll get into the multiplying and dividing. So before I simplify, I'm going to look ahead and factor. So I can't factor a coefficient out here, but I can factor a w, and that's going to leave me with 4w minus 3y times w plus y divided by 3y minus 4w times 5w plus y. Well, let's look here. It doesn't look like anything can cancel out because nothing is exactly the same. I cannot cancel this w plus y out with this 5w plus y, because even though they're both w plus y, this one has that 5 in front of the w. But pay attention to this term and this term. And they are very close. They're just flip-flopped. And with the minus, I can get them to look the same by factoring a -1 out of one of them. So I'm going to take this numerator and factor a -1 out of it, and that's going to make this 4w a negative, and it's going to make this 3y a positive. So it's positive 3y minus 4w times w plus y over 3y minus 4w times 5w plus y. Now you can see that these are the exact same and can cancel out. And simplify it, I get -w times w plus y divided by 5w plus y. So here we're simplifying these expressions, and there are two rational expressions being multiplied. But notice for these two types, they're all monomials. There's no binomial or trinomials in it. We've done this before. You're just simplifying. You can cross cancel, you can multiply straight across and then simplify. I'll do it both ways. So for this one, if I multiply straight across first, that's going to be 6 times 15 is 90. C times C is C squared, and D squared isn't being multiplied to anything. 5D times 8A becomes 40A times D. And now I can reduce. These will reduce by 10, so that becomes 9 over 4. The C squared has nothing to cancel out with. The A has nothing to cancel out with, but the D does. And remember, you're subtracting your exponents here, so that's D to the first on the top, and that's what I get. I can also do it by cross cancel. If I go back here, 5 cancels out with this 15, and that makes that 3. These can both reduce by 2. The D can cancel out, and that's just going to make that D. So I'm left with 3 times 3 is 9. C squared D to the first divided by 4A. I still get the same answer. And the next thing we're doing is dividing. And this is one that should be pretty common by now. Instead of dividing by a fraction, we're going to multiply by its reciprocal. So I'm going to rewrite it, and I'm going to multiply by the reciprocal, which is 35a squared b over 12x squared y. I will look at cross canceling here. 7 goes into 35 5 times. 6 both goes into 18 and 12. I'll multiply across here and then reduce the variables. So this is going to be 15x y cubed a squared b over a squared b squared x squared y. That's 2a squared b squared x squared y. The x's can reduce, and that's going to leave the x in the denominator. The y's can reduce, and that leaves y squared in the numerator. Remember, I'm subtracting my exponents. The a's cancel out altogether. The b's is left with a b in the denominator. So this is my simplified form. So these are the ones that are going to be new. And you don't have to multiply them. I'm actually going to follow these 3 steps. Factor everything, cross cancel out your common factors, and then multiply straight across. So I'm going to factor this numerator, this denominator, and this one can't be factored. So I'm left with this, the first quadratic factored into x minus 8 times x plus 2. It's denominator factored into x minus 8 times x minus 8, and this denominator factored into x plus 3 times x plus 2. Now I'm looking to cancel out anything that is in the numerator and also common in the denominator. So I can cancel out this x minus 8 with this x minus 8. I'm not going to be able to cancel 1 out on the top and 2 out in the denominator normally. You have to do basically 1 for 1. But in this case, because I have 2 in the numerator, 1's over here, and 2 in the denominator, I can cancel these 2 out and then go and cancel these 2 out. I also have this x plus 2 is going to cancel out with this x plus 2. So since I don't have anything left in the numerator, I'm going to leave that as a 1. And the only thing left in the denominator is x plus 3. I'm left with 1 over x plus 3. And that's the simplified form. Now you are going to have to label your restrictions. In this case, x is not allowed to equal negative 3. Well, remember you got to go back to before you canceled out these common factors. So it's going to be x cannot equal negative 3, negative 2, positive 8, and positive 8. Well, because those are the same, I only need to write it once. So x cannot equal negative 3, negative 2, or positive 8. And in this case, I'm dividing these rational expressions. And just like the last one, whenever you're dividing by a fraction, we're going to multiply by its reciprocal. So I'm going to flip this one and multiply by its reciprocal, but I'm also going to factor them kind of in the same step. So this numerator becomes x minus 4 times x plus 4. It's the difference of squares. And this one I can actually factor out a 12 as the greatest common factor. And in this one, remember I'm writing this one in the denominator and this one in the numerator, and I factored them like this. Do remember, if you're changing this to a multiplication, you do need to multiply by the reciprocal. So now I can cancel the common factors out. I have x minus 4, x minus 4. X minus 8 isn't going to cancel. This y plus 3 will cancel. And so I'm left with x plus 4 times y minus 6 over 12 times x minus 8. That is my simplified form. And my restrictions are, okay, from this denominator I have y cannot equal negative 3. From this one, I have x cannot equal 4 and x cannot equal 8. But I also need to include these in this restriction. And the reason is because those originally were in the denominator. So with the dividing problem, you're getting your restriction from this denominator, and because you're going to write that and write the reciprocal of it, you also need to get it from here. So you're getting your restrictions from all three of those parts. So it's also y cannot equal 6, and this one would be negative 3 again. So those are my restrictions. And the last type you might see like this. All this is a division problem. It's a plus b over 4 divided by a squared plus b squared over 4. And that's it. Whenever you see it like this, change it to a division problem like this, and then you can multiply by the reciprocal. Well, nothing can factor here, but the 4's cancel out. I have a plus b over a squared plus b squared. This a squared plus b squared cannot be factored. It's not the difference of squares, and there's not the way you can factor a sum of squares. So this is the simplified form. All right, go ahead and pause it and try these 5, and I'll have the work set out in 5 seconds. Okay, so I have the work here. I'm just going to quickly, they factor out, things cancel out, your restrictions are labeled as well. So you have your answers here. If you have questions on any of these, you can ask me in class. This one, all the coefficients actually end up being the same when you multiply them together, so it equals a 1, and there's nothing left in the denominator, so it's all over 1. But when it's over 1 and the denominator all cancels out, then you don't need to really write it. For number 4, a lot of people will want to cancel out these x plus 3's. They're both in the denominator though, so I can't cancel them out. So it's just x plus 3 times x plus 3, or you can write it as x plus 3 squared as I did here. And remember, for the division, I'm getting my restrictions from these, and this one up here, but it was the same as that, so it didn't matter. For this last one, the x squared minus y squared is a difference of squares. It's x plus y times x minus y. My y plus 7's cancel out, and this x minus y can cancel out with this y minus x. What I need to first do is factor out a negative 1, and that makes this y a positive, makes this x a negative, and now I can cancel that out with this one, and I'm left with negative negative x plus y over y minus 7.